Hello everyone. This is the previous notes example. Yesterday someone asked me to explain this example. That's why I'm explaining here. If any doubt, ask me in group or personal message. Okay. Let's see. Show that beta of mn is equal to beta m plus 1 n plus beta of m n plus 1. See here I am taking first as a RHS part, that is the beta of m plus 1 n plus beta m n plus 1. Here I am using the relation between beta and gamma function. We know that what is the relation? It's a beta of mn is equal to gamma m into gamma n divided by gamma m plus n. I am using this formula here. See here, for m it is a m plus 1 first term, and the second part it is the for n it is a n plus 1 in second term. Okay, see, for a beta mn we write gamma m gamma n divided by gamma m plus n, but here for m it is a m plus 1. That's why I am taking gamma m plus 1 into gamma n divided by m plus 1, replacing gamma m plus 1 plus n. Okay, plus second term is beta m, for n it is a n plus 1. Okay, for that the relation is formula is what? Gamma m as it is. For n plus 1 it is a gamma n plus 1 divided by gamma m plus n, replacing n plus 1, that is a gamma m plus n plus 1. Okay, here I am applying the relation between beta and gamma function. Okay, next step. See here, we know that previous I am explaining the some standard proof on gamma function, that is the gamma n plus 1 is equal to n gamma m. Okay, if you see here, I will show in notes if you want. See here, recursion formula for gamma function. Prove that gamma n is equal to n minus 1 gamma n minus 1. If the n is the previous, its term is n minus 1. That's why gamma n is equal to rewritten n minus 1 gamma n minus 1. Already I proved in previous class, explaining also. Okay, I am applying this formula here. Okay, let's see the solution. Okay, applying that formula. For m plus 1, previous term is m. That's why m, gamma n as it is. Next, this term as a rewritten m plus n plus 1 plus. In second term, gamma n plus 1 can be rewritten n gamma n using a similar standard formula, divided by gamma m plus n plus 1. Okay, see here, taking the LCM, and the LCM is gamma m plus n plus 1. The first term, in both terms, common term is what? Gamma m into gamma n. Take outside. Okay, remaining part is what? M plus n. Okay, see here, as a numerator is as it is, that is gamma m into gamma n in bracket m plus n divided by, see here, once again I am applying the standard formula of gamma function, that is recurrence, that is the gamma m plus n plus 1. Its previous term is m plus n. That's why I am applying m plus n gamma m plus n. Okay, now m plus n get cancelled. Remaining part is gamma n into gamma m divided by gamma m plus n. Applying once again a relation between beta and gamma function, we get a beta of, that is the beta of mn. So this is the proof of the example. Okay, hope you understand this example. Next, come to the some more examples. Evaluate integration 0 to 1 dx divided by square root of 1 minus x cube. See here, in integration limit is what? 0 to 1. Then understood that must be a beta function. If it is in the form of integration limit 0 to infinity, that must be a gamma function. Okay, once again I will explain. If the integration limit is 0 to 1, then that must be a applying beta function. Okay, if the integration limit it is the in the form of 0 to infinity, infinite form, then that must be a gamma function. Okay, let's see some example. See here, they given 0 to 1 and dx divided by square root of 1 minus x cube. See here, this square root can be taken in numerator. Okay, what you get? Integration 0 to 1, 1 minus x cube raised to minus 1 by 2 into dx. Okay, if limit is 0 to 1, must and should have to apply beta function. For a beta function is what formula? Beta of mn is, definition is what? It is in the form of 0 to 1, x raised to n minus 1 and 1 minus x raised to n minus 1 into dx. Okay, we do not have x, but we have a 1 minus x form. Okay, we have interchange that power of 1 minus x. It's not, it can be converted into positive term. Okay, first see here, it is in the form of 1 minus x form. Okay, we must convert into 1 minus x cube can be converted into 1 minus x form. Okay, that's why I'm taking x cube as a t, because definition of beta, it is in the form of x 1 minus x. Okay, x does not appear, but 1 minus x is as form is there. That's why I'm taking x cube as a t. Okay, then what is the x power? X is equal to t raised to 1 by 3. Okay, then differentiate, where to get dx as a t raised to 1 by 3. Differentiation is 1 by 3 as it is, t raised to 1 by 3 minus 1. Put that values in the integral part. Okay, 1 minus x cube is a t and the power is minus 1 by 2, and dx is what? 1 by 3 into t raised to 1 by 3 minus 1 into dt. Okay, some correction is there in dx, put in the dt. Okay, let's see some. Next, see here, first take as a t first, because the beta function in the form of x 1 minus x, here x can be replaced as a t. It is in the form of t form. Okay, 1 by 3 is a constant, take outside, remaining part is integration 0 to 1. First taking the t power, the t raised to 1 by 3 minus 1. Next is a 1 minus t raised to minus 1 by 2 into dt. Okay, we know that already the power of in beta function mn, that is the power of x and 1 minus x must be in the positive term. That's why I am converting that power of the t and 1 minus t, 1 by 3 it is as it is, the positive does not interchange, but 1 minus t power is minus 1 by 2. It can be rewritten as a 1 by 2 minus 1 into dt. Now it is in the form of integration 0 to 1. Make a correction as a print mistake. They do not print the limit of 0 to 1. Okay, 1 by 3 integration 0 to 1, t raised to 1 by 3 minus 1, 1 minus t raised to 1 by 2 minus 1 into dt. Okay, applying the definition of the beta function, what to get? 1 by 3 is a constant, beta of m power is a, that is 1 by 3, then n is a 1 by 2. Okay, once again here applying the relation between beta and gamma, that is 1 by 3 is a constant as it is. For m it is a 1 by 3, for n it is 1 by 2, that is a gamma m, gamma n divided by gamma m plus n. Applying that formula, we get a gamma 1 by 3, gamma 1 by 2 divided by gamma 1 by 3 plus gamma 1 by 2. Okay, we know that already in previous gamma 1 by 2 value is the square root of pi. Okay, put that value, what you get? 1 square, gamma 1 by 3, gamma 1 by 2 is the square root of pi divided by 3 as it is. Then take LCM for gamma 1 by 3 plus gamma 1 by 2, we get a gamma 5 by 6. So this is the solution of the example. Okay, next come to the show that integration 0 to infinity e raised to minus x square into x raised to 2n minus 1 into dx. See here, the limit of the integral is in the form of 0 to infinity. Okay, now we have to applying the definition of the gamma function. Okay, let's see. For taking the LHS part, integration 0 to infinity e raised to minus x square x raised to 2n minus 1 into dx. We know that the gamma function definition is gamma n is equal to integration 0 to infinity e raised to minus x raised to n minus 1 into dx. Okay, see here, but we have a e raised to minus x square. That's why I am taking, it is in the form of e raised to minus x. That's why I am taking here x square, putting the, get in the form of e raised to minus x. That's why I am taking x square as a t. Okay, what is x value? We get a t raised to 1 by 2. Then dx is 1 by 2 t raised to 1 by 2 minus 1 into dt. This will put in the equation. First here, see here, LHS part, integration 0 to infinity e raised to minus x square as it is. See here, the x power is in the form of 2n minus 1. Okay, we do not separate the x square for putting the t value. That's why the rewrite the power of the x, 2n minus 1 can be rewritten 2n minus 2 plus 1. Once again you solve, you get a 2n minus 1. Okay, we have to rewrite the power of the x because of the putting the t value for in the replacing the x. X raised to 2n minus 1 plus 1 dx as it is. Okay, once again integration 0 to infinity e raised to minus x square as it is. X raised to 2n minus 2 taking first term, x the power is 1 taking a, that is a raised to m plus n is a what? A raised to m into a raised to n. Applying that formula, we get x raised to 2n minus 2 into x into dx. Okay, then integration 0 to infinity e raised to minus x square as it is. X, the 2n minus 2 is the common, take outside, we get a n minus 1. X as it is, x into dx. Now put the value of the x square as the t. In integration, what you get? Integration 0 to infinity e raised to x square is the t minus t, and x square is t, that is t raised to n minus 1, and x is what? T raised to 1 by 2, and the dx is 1 by 2 into t raised to 1 by 2 minus 1 into dt. Okay, put that these all values. See here, already x is a what? T raised to 1 by 2, and t raised to 1 by 2 minus 1 is what? Minus 1 by 2. That's why I'm taking in the denominator the t raised to 1 by 2. Okay, t raised to 1 by 2, t raised to 1 by 2 get cancelled. 1 by 2 is a constant, take outside, remaining part is what? Integration 0 to infinity e raised to minus t, t raised to n minus 1 into dt. Make it correction here, dt is not print here. Integration 1 by 2, integration 0 to infinity e raised to minus t, t raised to n minus 1 into dt. Once again applying the definition of the gamma function, what you get? 1 by 2. For ax it is the t, that is e raised to minus x, x raised to n minus 1 into dx. Is replacing a t as a, we get a gamma n. So this is the solution of the example. Next take, see here, 10th one is left, you will try. Already it is solved. It is similar to the beta function. See once again, the limit is 0 to 1, the x is there, 1 minus x is there, they put the value. See here, for a 10th example, x cube is there and x square is there. Okay, which is the smallest power that you have to take the variable. The power is 3 and power is 2. Which is smallest? 2 is the smallest. That's why I'm taking x square as the t. Okay, not take the maximum power. See here, next one, first one, this 10th one left to you guys. Next, take down problems on beta and gamma function. This is a very important examples. They will ask for 5 marks. Let's see. Prove that integration 0 to a x raised to 4 square root of a square minus x square dx is equal to pi a raised to 6 divided by 32. We have to prove that what is the pi a raised to 6 divided by 32. Okay, let's see the taking the LHS. See here, it is in the form of the limit is 0 to a. Okay, if the limit it is in the finite form 0a, then it is must be a beta function. If the limit in the form of 0 to infinite form, then must be a gamma function. If they are taking as a constant a, because you have to take a, it may be 1. That's why it is applying the beta form. Okay, let's just take down integration 0 to a x raised to 4 as it is. See here, integration a square minus x square into dx. See here, for a beta, it is in the form of definition is what? X 1 minus x. Okay, but we have a, for a, in square root we have a what? A square. That's why we replace in the form of 1 minus x. That's why I am taking a square as a common in square root. What to get? 1 minus x square divided by a square into dx. Once again, see here, the x is the power is 4 and the x divided by the power is 2. Which is smallest? 2 is the smallest. That's why I am taking x square divided by a square as the t. Okay. Next, what is the x by a? That is thus taking the square root, we get a t raised to 1 by 2. Okay. Then x equal to what? A t raised to 1 by 2. Then differentiate dx. A is a constant as it is. T raised to 1 by 2 is a 1 by 2. T raised to 1 minus 1 by 2 minus 1 into dt. Okay. As the variable changes, limit also changes. You put x equal to 0. What you get? T equal to 0. If put x equal to a, t equal to 1. So this is the see here. Now the limit is changed 0 to a to 0 to 1. Okay. These are put in the integral part. What you get? 0 to a can be replaced 0 to 1. Next, what is the x value? That is a t raised to 1 by 2. Put that value a t raised to 1 by 2 raised to the power is 4. And the a is a constant as it is. Then square root of 1 minus x squared by a square is as a t. And dx value is what? A by 2 into t raised to 1 by 2 minus 1 into dt. Okay. Next come to the take a is outside. Integration 0 to 1. See here. Multiply this a, the power is a raised to 4 and t raised to 1 by 2 into 4, 2 1s are 2 4s are, we get a t square and the 1 minus t, the power is 1 by 2, okay, and the a by 2 taking outside and t raised to 1 by 2 minus 1 dt as it is. The constant term a into a by 2 taking outside, we have to get a square divided by 2, remaining part integration 0 to 1, the a power is 4 and t 2 and 1 minus t raised to 1 by 2 and t raised to 1 by 2 minus 1 into dt. Okay. Once again solve. Once again the constant term a raised to 4 is there. Take outside. The remaining part is what? The constant term taking outside a raised to 2 already there. The a power 4 taking outside we get a raised to 6 divided by 2. The remaining part is integration 0 to 1. T raised to, the first term is 2, the last term is 1 by 2 minus 1. 1 by 2 minus 1 is a minus 1 by 2 and is also 2. Then we get a t power is 2 minus 1 by 2. Okay. Next, remaining 1 by t, the power is 1 by 2. It can be rewritten as 1 minus 1 by 2 into dt because we have to convert in the form of x is to m minus 1, 1 minus x is to n minus 1 into dx because it is a beta function. Okay. See here, the a raised to 6 divided by 2 as it is, integration 0 to 1, the t power 2 minus 1 by 2, it is a 3 by 2. Okay. 1 minus t raised to 1 minus 1 by 2 as it is. Okay. Once again, t raised to 3 by 2 can be, the power 3 by 2 can be rewritten in the form of m minus 1. That's why I am taking 5 by 2 minus 1. If you solve the 5 by 2 minus 1, once again you get 3 by 2. 3 by 2 can be rewritten as 5 by 2 minus 1. Okay. Then 1 minus t, it is the 1 minus 1 by 3, it is what? It is a 1 by 2. 1 by 2 can be rewritten in the form of 3 by 2 minus 1 because it can be rewritten 1 minus 1 by 2, but we have to replace in the form of n minus 1, not a 1 minus n. Okay. That's why I am replacing 1 minus 1 by 2 value is 1 by 2 that can be rewritten in the form of 3 by 2 minus 1. Okay. T power it is once again I will explain. Here t power is 3 by 2. It can be replaced as a 5 by 2 minus 1. And the 1 minus t power is 1 by 2. It can be replaced as a 3 by 2 minus 1 into dt. Now it is in the form of definition of the beta function, that is the integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 into dx. That's why see what is the m value now? 5 by 2 and n value is a 3 by 2. Okay. That can be rewritten. Constant term is what? A raised to 6 divided by 2 as it is. That is a beta of 5 by 2, 3 by 2. Once again applying the, we have to prove is what? In the form of 5 a raised to 6 divided by 32. Okay. Once again we have to apply for a beta function, applying the relation between beta and gamma function. That is a gamma m into gamma n divided by gamma m plus n. Okay. That is the gamma 5 by 2, gamma 3 by 2 divided by gamma 5 by 2 plus 3 by 2. Okay. See here, it's a very important step here. A raised to 6 divided by 2 is a constant, take as it is. See here, 5 by 2 can be replacing, applying the formula, that is the gamma n plus 1 is equal to n gamma n. Okay, applying this formula, 5 by 2 can be replaced as a, it can be rewritten as a gamma 3 by 2 plus 1. Once again, it is a 5 by 2, and gamma 3 by 2 can be written as a gamma 1 by 2 plus 1. It is in the form of gamma n plus 1. Then applying the formula, what you get? 3 by 2 gamma 3 by 2. Okay. Once again, for second term, gamma 1 by 2 plus 1 can be, applying the formula, we get a 1 by 2 gamma 1 by 2. Okay. See here, it can be continue the process for the gamma function up to we get a gamma 1 by 2, because we have to find in finite standard value. Okay, that's why not in the gamma function, it is only constant value here. That's why a raised to 6 divided by 2, 3 by 2, gamma once again 3 by 2 can be rewritten as a 1 by 2 plus 1. Okay, this 1 by 2 as it is, gamma 1 by 2 as it is, 2 divided by 2, gamma 5 by 2 plus 3 by 2, it is what? Take a LCM, we get a 2, 8 by 4, 8 by 2 is a gamma 4. Okay, a raised to 6, 3 by 2 as it is, gamma 3 by 2 can be once again a written a standard formula applying 1 by 2 gamma 1 by 2, because 3 by 2 is a 1 by 2 plus 1. Applying the formula gamma n plus 1 equal to n gamma n, we get a 1 by 2 gamma 1 by 2, and replacing remaining as it is 1 by 2 gamma 1 by 2 divided by, see here, square root of 4, that is gamma, sorry, not a square root, it is gamma 4. Gamma 4, that is gamma n, is equal to, applying the nth one standard formula, that is gamma n is equal to n minus 1 factorial. Applying that formula, okay, that is a 4 minus 1 factorial. See here, in this term, the 2 denominator 2 is not printed, make it correction. The more some print mistakes are there in textbook. Okay, next, see, next step, a raised to 6 divided by 2. See here, gamma 1 by 2, they have a 2 times, gamma 1 by 2, gamma 1 by 2. We know that gamma 1 by 2 what? Square root of pi. The 2 times we get a pi. Okay, 3 pi divided by, totally we have a 2. 2 is a 3 time for a denominator, we get a 2 into 2 into 2, and 4 minus 1, it is a 3. 3 factor is a 6. Okay, solve it, we get a pi a raised to 6 divided by 32. So this is the solution of the example. It's a very important question. They'll ask for 5 marks. Okay, next, these are the similar example left to you guys. If you have, if do not understand, ask me on group. Okay, thank you.